So during that transmission, there are chances of data loss or data damage. So before a data is transmitted from sender to receiver, sender and receiver, they will have an agreement of number of frames. From the sender, he is going to transmit the data unconditionally, continuously, simultaneously to the receiver end. It has been acknowledged here, and it has to wait for acknowledgement for 1 and 2 data packets. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the unit 2, that is data link layer. So in this session, we are going to talk about Hamming code and unrestricted simplex protocol, simplex stop and wait protocol, a simplex protocol for noisy channel, and sliding window protocol. See, these are the topics to be discussed in this session. Okay, let us start. The first one is called Hamming code. So, what is a Hamming code? Hamming code is a technique. It is a technique which is an error detection and correction technique. So, in the previous session, we have learned about different types of error detections methods. So, one of them is Hamming code. So, it is one of the technique for error detection and error correction. And it was proposed by R.W. Hamming. And whenever a data packet is transmitted over a network, there are possibilities that the data bits may get lost or damaged during transmission. So it is possible over network. Whenever the data is transmitted over a network, it has to cross maybe number of networks or number of devices, so on. So during that transmission, there are chances of data loss or data damage. Then we can say that there is an error. So this is the error. So there is a possibility of errors during transmission. So the redundant bits or some extra bit or binary bits that are not part of original data, and they are generated and added to the original data bit. So what is a Hamming code? So the Hamming code has to be generated, and that is called a redundant bit, and that is and this Hamming code, it even works for even parity check. So in that case, the original data will be there, and in addition to it, this Hamming code is generated, and that Hamming code with the data together, they are going to transmit over the network to the receiver. So here, the first step is to generate a Hamming code that will be added or appended to the original data. Then data plus Hamming code will be transmitted over the network. Now, with the help of this formula, it is possible to get a Hamming code or even parity bit. And this is one of the error detection and error correction technique. Now in the next slide, we will see what are data link protocol. So now we know what is a data link layer in OSI reference model. So it is a second layer in OSI reference model. So here, this data link layer protocol, this transfers data between nodes on the same local area network segment or between adjacent nodes in the wide area network. So what is the one of the function of data link layer is, or the protocol is, transfer of data between the nodes of the same network or within the LAN, or another function is to transmit the data between two different network or WAN, wide area network. So this data link protocol specify how devices detect and recover from such collisions, and then provide mechanism to reduce the or prevent the collision. So another responsibility is to avoid collision during data transmission. Next, DLL protocols can be divided into two. They are elementary protocols and sliding window protocol. See, these are the protocols in data link layer. So main responsibility of data link layer is to transfer the data is within a network or in a network in a local LAN or with WAN connectivity or with wide area network, that is WAN. And also it avoids collision during data transmission over network or across the network. Now there are two types. One is elementary protocols. Second one is sliding window protocol. Now let us see what are elementary protocols. And here elementary protocols are further divided into three protocols. They are an unrestricted simplex protocol and simplex stop and wait protocol and simplex protocol for noisy channel. These are the three protocols in elementary protocols of DLL. Now, what is unrestricted protocol? Unrestricted simplex protocol. So, the data is transmitted only in one direction. So, here the data is transmitted one direction, I mean from sender to receiver. That is one of the feature of this, and both the network layers are always ready for transmitting and receiving the data. So both the network layers of sender and the receiver side, they are ready to, one is to send the data and one more is to receive the data. So this is a data transmission takes place in only one direction. And here this protocol consists of two procedures, that is sender and receiver. So here sender, from the sender data is transmitted to the receiver. The receiver is to receive the data sent from the sender. So this is unrestricted simplex protocol. Now in the next slide we will see what is simplex stop and wait protocol. So what is stop and wait protocol? So here we have to deal with the problem of flooding. So what is the flooding here? The meaning of flooding is, suppose the data is transmitting from the sender end continuously to the receiver end. So the meaning here is, so from the sender, he is going to transmit the data unconditionally, continuously, simultaneously to the receiver end. So during transmission, all the packets are moving towards a different network devices in a network. So it is a sort of flooding. So there is nothing but unconditional transmission of data from sender to the receiver end. So in which the sender sends the data continuously to the receiver and condition like flood is created at the receiver end. So this is called a condition. Suppose a continuous data is sent from the sender to the receiver end. At the receiver end, they are finding the condition like a flood. To prevent this, we are using stop and wait protocol. So to avoid this flooding during data transmission in the network, we are using stop and wait protocol. So here this is with respect to acknowledgement, in the sense the sender send the data and wait for acknowledgement. So till the acknowledgement is received, until the acknowledgement is received from the receiver, so till the time the sender, he will not transmit the data to the receiver. So this is a sort of a technique or a method to avoid flooding in networking. Next one is a simplex protocol for noisy channel. So what is the meaning of this? So according to this, it deals with noisy channel. Next one is the main task is of acknowledgement which is received from the receiver. So this works with the concept of acknowledgement from the receiver for the data packets which has been received from the sender. The receiver sends back a positive and a negative acknowledgement, and after receiving the acknowledgement, the sender starts sending the data once again. So this is the process where the sender sends the packet to the receiver. At the receiver end, it has to be all the packets which has been received from the sender, it has to be acknowledged. Then after receiving the acknowledgement from the receiver, then the sender starts sending the frames or data packets again. So this is simplex protocol for noisy channel. Now in the next slide we will see another protocol is sliding window protocol. So what is the concept of sliding window here? So in this method, sender transmits or sends various frames or packets before receiving any acknowledgement. Again, it also deals with the acknowledgement concept here. So here, any data sent from a sender, it has to be acknowledged by the receiver end. But before getting any acknowledgement from the receiver, sender can transmit n number of packets or data to the receiver. That is the meaning of the sentence here. So it is a point-to-point protocol. So it means that, it assumes that none of the other entity tries to communicate until current data or frame transfer gets completed. So one of the point is that, so it is the concept of point-to-point protocol. So once the sender has sent the data to the receiver end, till it completely transmits the data to the receiver, till the time. So no other transmission takes place between the sender and the receiver. So that is the second point. So here, both sender and the receiver agree upon a total number of data frames after which acknowledgement is needed to be transmitted. So here, before the sending a data from the sender to the receiver end, both the sender and the receiver, so they will come to an agreement about the total number of frames can be transmitted without acknowledgement. See, this is the point number 3. Next one is the data link layer requires and uses this method that is simply allows sender to have more than one acknowledged packet in flight at a time. So here, what is the meaning of the sentence here? It requires and uses this method that simply allows sender to have more than one unacknowledgement packet at a time. It is possible. So there are situations where the sender, he may not receive the packets or acknowledgement for the packets. And using this method, sender can transmit the several frames before getting an acknowledgement. See, that is what the point we have seen in our previous slide. The sender, he will not wait for the acknowledgement for each and every packet from the receiver end. And here, the receiver can send the acknowledgement for multiple frames at once. So here, a single acknowledgement for multiple frames. So frame can be acknowledged even when the window is not completely filled. So this is a sliding window protocol. In the next slide, when the receiver sends the acknowledgement, it includes the number of the next frame that it wants to receive. And for example, to acknowledge the string of frames ending with the frame number 4. For example, if there are 4 numbers, the receiver will send acknowledgement containing the number 5. Suppose the receiver has to send the acknowledgement for 4 frames, but the receiver will send the acknowledgement containing the number 5. Means, receiver, he sends the acknowledgement for one more frame here, that is frame number 5. So, when the sender sees the acknowledgement with the number 5, this number 5, and it got to know that the frame from 0 to 4 are through and have been received. At the receiver end, instead of sending the number 4, suppose he may send the acknowledge the frame number 5, then it is at the sender end, it is understood that all the previous frames which had been transferred or through or received by the receiver. So this is the concept here. In the next slide, we will see the diagram of sliding window. See, this is a sliding window, this is a frame, and this is also a frame. Here in this example, the size is 1, 2, 3. There are 3 frames here included or can be accommodated in this frame. So this is a frame concept here, and look at the diagram here. So this is sliding window. Again, the same what you have seen in the previous. The window size is 3. See, this is what you have seen in the beginning. So before a data is transmitted from sender to receiver, sender and receiver, they will have an agreement of number of frames or window size. In this example, window size is 3. This is one window. Look at another diagram here. See, this is the sender and this is the receiver. So the sender, he will send 0. This is one frame here and second frame and frame number 2 here in this example. So, but he got the acknowledgement only for at once for 0. See, this is arrow mark from here. The meaning here is that the data packet sent from sender 0, it has been acknowledged here, and it has to wait for acknowledgement for 1 and 2 data packets. So this is at the receiver end. So this is how the sliding window concept works. In the next slide, see how exactly the sliding window works here. So both the sender and receiver has finite size buffers called windows. See, that is what you've seen in the previous slide. So before sending data from sender to receiver, both of them will agree upon window size or number of frames in the window. The sender and receiver agrees upon the number of frames to be sent upon the buffer. That is the meaning of buffer size. The sender sends multiple frames in a sequence without waiting for acknowledgement. When it's sending, the window is filled, it waits for acknowledgement. So in the previous slide, see, the sender, he will send multiple frames. He's going to send multiple frames at once here, and he'll wait for acknowledgement. Now on receiving the acknowledgement, it advances the window and transmits the next frames according to the number of acknowledgement received. So on receiving the acknowledgement, okay, so if you look at this example, so here, so once the receiver has been sent the acknowledgement for the frames or the data packet has been sent, so then it will wait for, then it starts sending another frames. Now in the next slide, beginning of transmission, the sender window contains n-1 frames, and when they are sent out, the left boundary moves inward, shrinking the size of the window. What is the meaning of this? At the beginning of the transmission, the sender window contains n-1 frames. If you look at the example here, in this one, we have seen that size is 3. So size is 3 means n-1 means, suppose there is 0, 1, 2. You start from 0, so 0, 1, 2. So this is n-1. So this consists of 3. There are 3 frames in a window. Now, for example, if the size of the window is W, if the size of the window is W, if there are 3 frames sent out, then number of frames left out will be in the center is W minus 3. So if the size is W, W minus 3, that is the left out frames in the window. Once the acknowledgement has arrived, then the sender window expands to the number which will be equal to the number of frames acknowledged by the receiver. So here, once the acknowledgement has been arrived, then the sender window expands to the number of frames equal to the acknowledgement received by the receiver. The meaning of the statement is, once the acknowledgement has received for 1, in this example, there are 3 multiple frames, and then the sender has received acknowledgement only for 1 packet. So once the acknowledgement has received 1 packet, so the sender window, he can include only 1 frame in the window. That is the meaning of this. So suppose if we get there are 2 acknowledgement for 2 frames, then here the 2 frames will be free. So the sender can accommodate, or you can include 2 more frames into the window. So that is the meaning of the sentence here, according to the number of acknowledgement received. Next one is at the receiver window. So at the beginning of the transmission, the receiver window does not have contain any frames because the sender has to send the data. So all the data packets will be in the frame as per the window size. Before the data transmission, so the data frames or the window at the sender end is filled with n-1 frames. Okay, but at the receiver end, there are no frames as it has not received any data from the sender. So it is n-1 spaces will be available. Suppose if there are 4 frames, so here there are 4 frames, that is n-1 frames, and here 4 spaces will be available, or 4 frames are free in a window. So when the new frame arrives, the size of the window shrinks. The receiver window does not represent the number of frames received, but it represents number of frames that can be received before the acknowledgement is sent. So here, when the new frame arrives, so when the new frame is received at the receiver end, actually the size of the window shrinks. So what is the meaning of the concept here? See, so at the beginning, if you take example, now there in a window, there are 3 frames. So this is 0, 1, 2. Once the new frame arrives from the sender end, so it is going to occupy one place here. In that way, there are 2 space here, or we can say in a window, there are 2 frames can be accommodated. So here, the size has been reduced from 3 to 2. That is the meaning of it is the window at the receiver end is going to shrink as and when it receives the frames from the sender. And once the acknowledgement is sent, the receiver window expands by the number equal to the number of frames acknowledged. In this example, for this data from frame 1, 0, suppose the receiver sends the acknowledgement for this. Again, this will be free. So again, there are 3 frames can be accommodated in a window. That is the meaning of the sentence, last sentence here. Now let us see what are the advantages of and disadvantages of sliding window concept. So here in advantages, it performs better than stop and wait flow control. See, this is what are the one protocol we have seen in our previous slides, and this method increases efficiency. Another advantage, and multiple frames can be sent one after another. So because at the receiver end, the receiver he may acknowledge for one acknowledgement for multiple frames received from the sender. These are the advantages and disadvantages. It is main issue is complexity at the sender and the receiver end due to transferring of multiple frames. So this could be the one of the reason, one of the drawback of this. The receiver might receive data frames or packets out of the sequence. So these are the drawbacks of or disadvantages of sliding window protocol. Students, let us continue our discussion in my next session. Thank you so much.